Hi guys, welcome to this video on the 2019 Level 3 differentiation paper. So question 1, differentiate y equals the square root of 3x squared minus 1. Alright, so for this question we cannot differentiate straight away with the square root, so we're going to rearrange and make it 3x squared minus 1 to the power of 1/2. So our y equals to 3x squared minus 1 to the power of 1/2. And now we can apply our chain rule in order to find our dy over dx. So if we bring the 1/2 to the front, dy, let's try this again. So dy over dx equals to, we bring the 1/2 to the front, multiplied by our inner function, to the power of 1/2 minus 1, so negative 1/2, multiplied by the derivative of the inner function, which is derivative of 3x squared is 6x. So therefore we will have 3x over square root of 3x squared minus 1, because 3x squared minus 1 to the power of negative 1/2 is the same as saying 1 over square root of 3x squared minus 1. So this one should be your final answer, and looking at the mark schedule, which only came out probably 1 week ago, so this is just an achievable question. Question B. Find the rate of change of the function. So rate of change, remember when you see rate of change, that always refers to the derivative. So find the rate of change of the function f of t equals to 5 ln of 3t minus 1 when t equals to 4. Alright, so once again, we're going to be using our chain rule here. So 5 ln of 3t minus 1. So the derivative of ln 3t minus 1, that is 1 over 3t minus 1. Multiplied by the 5, and then multiplied by the derivative of this inner function here. So the derivative of 3t minus 1, that's just 3. So we'll have to multiply 5, and we have to multiply it by 3 as well. So this equals to 15 over 3t minus 1. And we need to substitute t equals to 4 to find the rate of change. So that's our f dash of t. So f dash of 4 equals to 15 over 3 times 4, which is 12 minus 1, which equals to 15 over 11. And putting this into our calculator, you can just leave your answer like this, or you can change it to a decimal form. If you change it to a decimal form, you should get that this is equal to about 1.36. And this is another achievable question. Find the gradient of the tangent of a curve y equals to e to the power of 2x divided by 1 plus x squared at the point where x equals 2. So in this case, we have e to the power, we have a numerator and denominator and a fraction. So I think the most appropriate rule to apply here will probably be the quotient rule. So the derivative of the top function multiplied by the bottom function minus the derivative of the bottom function times the top function divided by the bottom function squared. So I hope that was a big mouthful. So what I'm saying is the derivative of the top function, the derivative of e to the power of 2x is 2e to the power of 2x multiplied by 1 plus x squared minus the derivative of the bottom functions. The derivative of 1 plus 2x is just 2x multiplied by e to the power of 2x divided by 1 plus x squared. So that's our dy over dx. Alright, so it wants us to find the gradient where x equals to 2. So we can just directly substitute 2 into our equation. So dy over dx equals to 2e to the power of 4 multiplied by 5 minus 2x. 2 times 2 is 4. E to the power of 2x, so e to the power of 4 divided by 5 squared. So if we plug this into our formula, we should get, so just be careful with the brackets. So e to the power of 4 times 2 minus 4. 2e to the power 4 times 5 minus 4 e to the power 4. Right, you should get that your answer should come out to be 13.1. That's what I got. So 13.1. Yes, that is the answer. So this is a merit level question. And to get an achieved, all you need to have is the correct derivative. So with the derivative, you don't have to simplify at all. You can just leave it like this. That will get you an achieved. All right. Question D. So for what values of x is the function y equals to x cubed e to the power of x decreasing? So in this case, we have two functions, x cubed and e to the power of x multiplied together. So therefore, we're going to differentiate using the product rule. So the product rule, so if we say this is f of x and this is g of x. So basically what's saying that is that f dash of x times of g of x plus of f of x times of g dash of x. So the derivative of one multiplied by the non-derivative of the other one plus the non-derivative of the other one times the derivative of the other function. So dy over dx is equal to 3x squared e to the power of x plus of x cubed e to the power of x. Because the derivative of e to the power of x, that's still e to the power of x. So we want to find when it's decreasing. So first of all, we want to solve for when it's 0. Once we solve for when it's 0, we can find out when it's decreasing. So dy over dx, so we say it's first we just substitute 0. 3x squared e to the power of x plus 3. So notice that e to the power of x is a common multiplier, so we can just factor and cancel it out. So we can divide both sides by e to the power of x. So we have 0 equals to 3x squared plus x cubed. And solving this equation, just use it at this point. Just go to your calculator. So degree 3, 1, 1 and 3. So we got our I got x equals to -3 and x equals to 0. Alright, so looking at our graph, we should have, looking at this is the positive cubic. So looking at this graph, we should have something that looks like, alright, so it should look something like this. So this is our f dash of x. And we want to find out when it's decreasing. So therefore, so this here is -3. So when it's decreasing, that'll only be this part here. Because for all the rest of the cubic is going to be above the x-axis. So as you can see here, this whole thing is going to keep going upwards. It's always going to be above 0. So our only part where f dash of x is decreasing is when it's less than -3. So you can say when decreasing, x must be less than -3, because that's the only part of the cubic that's below the x-axis. So therefore, because this is the graph of f dash of x, it's going to be the only part where the function is decreasing. So that should be your final answer, and that should be a merit level question. To get an achieved, a correct derivative is all you need for an achieved. So up to this step here will get you an achieved. Question E. The volume of a cube is The volume of a sphere is increasing at the instant where the sphere's radius is 0.5 meters. The surface area of the sphere is increasing at a rate of 0.4 meters squared per second. So that's the surface area. So this is what they give us. So that's the rate of increase of the surface area. So you can say dA over dt is equal to 0.4 meters squared per second. And it wants you to find the rate at which the volume of the sphere is increasing at this instant. So it wants you to find dv over dt. So this will be a parametric equation. So we're trying to find dv over dt. So they give you dA over dt. So dv of dt equals dA over dt multiplied by something. So right now we have a dv we're missing, and we have a dA that we do not want. In order to cancel out the dA, we want to have a dA on the denominator here. So this dA and this dA, they will cancel each other out, and in its place we're going to be putting dv. So in this case, dA and dA will cancel each other out, and the dv will shift to the dt. So that we'll get dv over dt. So the function that we want to find here is now dv over dA. So dv over dA that we want to find. Alright, so we know that if we go to our formula sheet, we should find that the volume of the sphere is volume equals to 4 over 3 pi r cubed, and our area equals to 4 pi r squared. Alright, so as you can see, it's really difficult to find dv over dA. However, as you can see here, so v and a, there's a common r in both equations. So using this, to find this, we can use the common r in order to find dv over dA. So once again, another parametric, so dv over dA. So we can find that dv over dr here, and we can find dA over dr. So we want to find dv over dr, so we want dv at the top, and we want dA at the bottom. So right now we have dv and dA at the top, we want dA at the bottom. So therefore we're going to find the inverse of dA over dr, so dr over dA. That would be the inverse of dA over dr. So we can say that dv over dA equals to dv over dr times of dr over dA. So as you can see here, the dr here and the dr here will cancel out, and the dA will shift to this bottom space here. So that's just what we want. So we want to find the derivative dv over dr. So dv over dr equals to, so we're just going to be using a simple power rule here. So 3 times 4 over 3, that is 4 pi r squared. And we also have dA over dr equals to 8 pi r. Once again, it's the power rule again. That's dA over dr. We need to find the inverse. So dr over dA, that equals to 1 over 8 pi r. So therefore, our dv over dA is equal to 4 pi r squared over 8 pi r. Alright, so right now we can simplify this equation. So pi and pi cancel each other out, and one of the r's on the numerator will cancel out this r at the denominator. So what we're left with is 4r over a, which equals to half of r. So now we have our dv over dA. We can now multiply dv over dA and dA over dt to find our dv over dt. So dv over dt equals to r over 2 multiplied by 0.4, this 0.4 here. And that will give us 0.4 r over 2. Alright, so at the instant when the sphere's radius is 0.5 meters, the surface area is increasing at the rate of 0.4 meters squared per second. So it tells you that the radius is 0.5 meters. So therefore, our dv over dt equals to 0.4 times 0.5 over 2. And that should give us an answer of, let me just, 0.4 times 0.5 divided by 2, that should give us 0.1. And don't forget the unit. So looking at the unit, it's just this top one. The unit of volume is meters cubed, and the unit of time is seconds. So it will be meters cubed per second. That's our unit. And that should be our final answer. And this is an excellence level question. If you can get up to 0.1 meters cubed per second. To get a merit grade, correct expression for dv over dt. So dv over dt, so where is that? dv over dt, so if you can get up to this part here, I think is what it's saying. dv over dt, if you can get up to this step here, that's a merit grade. Correct expressions for ds over dr or dv over dr for an achieved. Okay, that's pretty lenient. So you can get an achieved for this step or this step here. That these are worth achieved grades. Alright, for question 2 now. So question 2, differentiate y equals to 2x minus 5 to the power 4. Okay, for this question, we're going to be using the chain rule again. So y equals to 2x minus 5 to the power 4. So we're going to bring the 4 down and then bring the power down by 1 and then multiply it by the derivative of the inner function. So dy over dx equals to 4 times of 2x minus 5. 4 becomes a 3 multiplied by the derivative of 2x minus 5. So the derivative of 2x minus 5, that's just 2. So therefore, you'll have dy over dx equals to 8 multiplied by 2x minus 5 to the power of 3. And that should be your final answer, and this should just be an achieved question. Yeah, this is an achieved level question for the derivative. Question B. Find the gradient of the tangent of a curve y equals to tan 2x at the point on the curve where x equals to pi over 6. Alright, so once again, the gradient of the tangent we need to differentiate. So if you look at your formula sheet, you can see that tan x differentiates to sec squared x. If I'm not mistaken, let me just double check that real quick. Yeah, tan x differentiates to sec squared x. Okay. So y equals to tan 2x. Therefore, dy over dx equals to 2 sec squared 2x. Remember, you have to multiply by the derivative of the inner function as well. So derivative of 2x is 2. So you need to times everything by 2. So it becomes 2 sec squared 2x. Alright, so we know that sec equals to 1 over cos x. So sec x equals to 1 over cos x. Therefore, sec x, I can't pronounce this properly. Sec squared x is equal to 1 over cos squared x. So in this case, it will become 2 over cos squared 2x. And we want to find the gradient when x equals to pi over 6. So that's our dy over dx. So dy over dx equals to 2 over cos squared of 2 pi, which becomes pi over 3. Alright, so substituting this in. So, oh yeah, remember your calculator should be set to radians. If you're on degrees, then you'll get the incorrect answer. So we're always working with radians here. So put your calculator on radians, not degrees. So cos pi over 3 squared. So 2 divided by 125. That should give us an answer of 8. And let me double check this one. Yeah, and 8 is the correct answer, and this will get you an achieved grade. Alright, moving on. C, a curve is defined parametrically by the equations x equals to 1 over 5 minus t squared and y equals to 5t minus t squared. Find the gradient of the tangent to the curve at the point t equals to 2. Alright, so we have a parametric equation here, so we want to differentiate both of them first with respect to t. So rearranging this first equation here, we'll get x equals to 5 minus t to the power of negative 2. Differentiating that, we'll get dx over dt equals to, bring the negative 2 down, so it becomes negative 2 5 minus t to the power of negative 3, multiplied by the derivative of 5 minus t, which is negative 1. So dx over dt is actually equal to 2 over 5 minus t cubed. On the other hand, we have y equals to 5t minus t squared. So therefore, dy over dt equals to 5 minus 2t. It's just the power rule there. Alright, so we want to find dy over dx. We have dy and dx on the numerator, but we want dx on the denominator. So we're going to find the inverse of dx and dt. So dt over dx equals to 5 minus t cubed divided by 2. So dy over dx equals to dt over dx times dy over dx. Not yet. What am I doing? Oh, sorry, dy over dt. Sorry, my bad. Dy over dt. So dt and dt will cancel out, and the dy will shift. Alright. So we'll have 5 minus t to the power of 3 times of 5 minus 2t over 2. So that's our dy over dx. And substituting t equals to 2 to find our gradient. So dy over dx equals to 3 to the power of 3. So 5 minus 2 is 3. So 3 to the power of 3 multiplied by 1 over 2. So what does that give us? What does that give us? 3 to the power of 3 is 27 divided by 2. It gives us 13.5. And that should be our final answer for this question. And this is a merit level question with an achieved being at correct expression for dx over dt, sorry. So dx over dt, that is this one here, that will get you an achieved. So I'm noticing that this does not give achieved, so does not give achieved grade for this one, because this one only uses the power rule while this one uses level 3 skills. So if you only find dy over dt, sadly you won't get any marks for that according to a mark schedule. So D, the Wynyard Crossing Bridge in Auckland can be raised and lowered to allow tall boats to sail through when open and pedestrians to walk across when closed. The bridge consists of 2 arms, each of length 22 meters. When the bridge is rising, the angle of the bridge arm above the horizontal increases at the rate of 0.01 radians per second. Find the rate at which the height BH is increasing when 15 meters above the horizontal, when h is 15 meters above the horizontal FB. Alright, so it gives you the change in angle that is 0.01 radians per second. And what you want to find is find the rate at which height BH. So dH over dt is what you want to find. So once again, dH over dt, that equals to d theta over dt is what we have, multiplied by something, okay? So we want to get rid of the d theta, so we're going to put d theta on the bottom here, so they'll cancel each other out, and we want dH to shift to the numerator. So we have this, so this is the hidden one that we want to find. So we want to find this one. So you want to find height in terms of the angle. So in this case, we can say that sine theta equals to h over 22, and therefore 22 sine theta equals to h, because that's just trigonometry, because as you can see here, the hypotenuse is here, opposite is here, adjacent is here, so O over h, that's equal to, that's the sine rule. So sine theta equals to the height over the 22 meters. So now we can find the derivative. So dH over d theta, that's equal to 22 cos theta. So now we can say 22 cos theta times of d theta over dt equals to dH over dt. So 22 cos theta multiplied by 0.01, that is our dH over dt. Alright, and we simplify this to 22 times 0.01. That should give us dH over dt equals to 0.22 cos theta. So find the rate at which height BH is increasing when h is 15 meters above the horizontal. So basically when the h is 15. So question is saying find dH over dt when h equals to 15 meters. So as you can see, we have theta in our equation. So therefore we need to find what is theta when h is 15. So what am I doing? So in this case, we can say that sine inverse of 15 over 22 is equal to our theta. So sine theta. Remember to be on radians right now. So that should give us theta is equal to 0.570 radians. And we can plug this into our dH over dt. So dH over dt equals to 0.22 and cos of 0.570 times 0.22. So that should give us dH over dt equals to 0.161, and the unit would be meters per second, because dH is in meters and time is in seconds, so meters per second. Alright, so for this question, getting up to the final answer here, that is a merit grade. To get an achieved grade, you're looking at dH over d theta. So finding the derivative, dH over d theta. So dH over d theta, that's an achieved. Alright, question E. If y equals to e to the power of u and u equals to sine 2x, show that the second derivative of d... Okay, just you can read that by yourself. That's a big mouthful for me. Alright, so first things first, we know that u equals to sine 2x. And we know that y equals to e to the power of u. So we can write that y equals to e to the power of sine 2x instead, because u and u here are the same. Alright, so we want to find dy, the second derivative. Okay, so it's dy over dx equals to cos 2x e to the power of sine 2x. And we want to find the second derivative, so d squared, probably not there, that's not enough space, d squared y over dx squared equals to, so now we have two functions, so now we need to use the product rule. So the derivative of cos 2x, that is, sorry, this is 2, sorry, I forgot to write the 2 there. So derivative of 2 cos 2x, that becomes negative 4 sine 2x, e to the power of sine 2x, plus of the derivative of e to the power of sine 2x, which is 2 cos 2x squared sine e sine 2x. So that's our d squared y over dx squared, second derivative. So now we need to find this whole right-hand side here. So this is our left-hand side. So we want to prove, but what we're proving is left-hand side equals to right-hand side. That's what we're trying to prove. So left-hand side, so second d squared y over du squared. So second derivative, so we'll get that. So e to the power of u, no matter how many times you differentiate that, that's still e to the power of u. And du over dx, so du over dx squared. So du over dx, that's equal to the derivative of this. So derivative of sine 2x, that's 2 cos 2x squared. So right now we have e to the power of u, 2 cos 2x squared, plus of the derivative dy over du. So dy over du, once again, that's just e to the power of u. And d squared u over dx squared, so the second derivative of sine 2x. So if we look here, so sine 2x, so that's u du over dx, that equals to 2 cos 2x, and d squared u over dx squared, that equals to negative 4 sine 2x. So all in all, we're going to have e to the power of u, 2 cos 2x squared, plus e to the power of u multiplied by negative 4 sine 2x. Alright, so know that e to the power of u, so u is sine 2x, so we can write e sine 2x, 2 cos 2x squared, plus e to the power of sine 2x, negative 4 sine 2x. So this is our left-hand, not left-hand side, this is our right-hand side. So now looking at this, we can say that our left-hand side is equal to our right-hand side because they're exact same. So 2 cos 2x squared e to the power of sine 2x, that's here. And negative 4 sine 2x e to the power of sine 2x, that's here. So therefore we can say left-hand side equals right-hand side, and therefore we have done as required. And this is an excellence level question, so if you get up to proving that they're equal, you'll get an excellence mark. To get a merit level mark, so d squared y over dx squared. So okay, so if you just find the left-hand side here, this whole expression here, you'll get an you'll get a merit grade. And to get an achieved, if you can find dy over dx, so dy over dx, that's here, that's an achieved, or du over dx, so du over dx. Or you can find du over dx here. Yeah, du of dx, yeah. That's also an achieved. Right. Question 3. Differentiate y equals to 4 over sine x. Do not need to simplify this. Okay. So once again, we have a fraction. So I think the best thing to use here is probably the quotient rule. So derivative of 4 is 0. So 0 times anything is just 0. So we can just ignore that. So now we can find derivative of the denominator. Sine 2x is cos, not 2x. The derivative of sine x is cos x. So it becomes negative 4 cos x over sine squared x. That should be our derivative. What did I do? Okay, so what they have here is the same. They just moved the sine squared x to the top. So yeah, this is the same thing. So this is an achieved level mark here. Yeah, okay. So the graph below shows the function y equals to f of x. Find all the values of x which meets the following conditions. The gradient function is 0, so the rate of change is 0. F of x is not differentiable. Okay, so f dash of x is 0, so that's when there is a stationary point. So that's here and here. Okay, so you can write that f dash of x equals to 0 when x equals to 2, and this is continuous. It keeps going. This keeps going forever. So you can say always x greater than 4. Okay, it's not equal to 4. Okay, so you might be tempted to write equals to 4, but that is incorrect. You'll get marked down because at x equals to 4, it is not differentiable because it's a sharp corner. It's a sharp turn. It is not differentiable. Therefore, the gradient function is not 0. So it's not differentiable at that point. So you have to write x is greater than 4. Do not write x is equal to 4 because that is incorrect. Question number 2, f of x is not differentiable. So that's when the graph is not continuous. So the graph has breaks in the graph, such as this point here. That is not differentiable, as well as sharp corners. Okay, so these are not differentiable either. So all of these points, we have x equals to -2, x equals to 1, and x equals to 4. And finally, what is the value of the limit of x approaching 1 of f of x? So when x approaches 1, as you can see here, the left hand side, the bottom and the top, they're not approaching it. They're approaching different values of y. Because they're approaching different values of y, there is actually no limit. So we can say that this does not exist. Alright, it's interesting. This is just an achieved mark. So for all, so 2 correct. Okay, so 2 correct. 2 of I. 1. This says 2 correct, I'm pretty sure. So any 2 correct will get you an achieved. So all 3 correct will also get you an achieved. Alright. Alright, a rectangle has one vertex at 0, 0, and the opposite vertex on the curve y equals to 4 minus root x, where x is between 0 and 16, as shown on the graph below. Find the maximum possible area of this rectangle. Okay, so the area of a rectangle, not red pen. Alright, so the area of a rectangle is equal to x times of y, where y is equal to 4 minus root x. So therefore our area equals to x times of x minus root x. Alright, so if we simplify this, we get a equals to 4x minus x to the power of 3 over 2. X to the power of 3 over 2, because square root of x is 1/2 times of x to the power 1, so 1 plus 1/2 is equal to 3 over 2. So that's how we got that answer there. Alright, so that's our area. We can find the derivative dA over dx equals to 4 minus 3 over 2. Take the power down by 1, so square root of x. Alright, so at a maximum turning point, the dA over dx equals to 0. So you can write at max dA over dx equals to 0. 0 equals to 4 minus 3 over 2 root x. Therefore, -4 equals to -3 over 2 root x. And therefore, if you divide both sides by -3 over 2, so -4 divided by -2, so we should get that 8 over 3 equals to root x. Squaring this on, so we should get that we should get this value for x. X should get 64 over 9, and therefore you do not need to prove that the area you found is the maximum. Okay, so we don't need to find the second derivative. We can just substitute x back into our area formula. So a equals to 64 over 9, 4 minus square root of 64 over 9. Okay. Alright, so square root of 64 over 9. Oh, sorry. Square root of 64 over 9. 4 minus of that times 64 over 9. Alright, I should have got that our answer is equal to 256 over 27 units squared. Or in the decimal form, it would be 9.48 units squared. And that is our final answer. So that's either in the fraction form or the decimal form. Both are acceptable for a merit grade. To get an achieved grade, a correct expression for the derivative of the area. So if you find the correct derivative, you'll get an achieved. Sorry, that's a U grade. Alright, question D now. Question D, the velocity of an object is modeled by the function v equals to e to the power of t plus 8e to the power of negative t for t is greater than or equal to 0. Alright, find the time of this. So we need to find the time when the acceleration of the object is 0. Alright, so we need to find the derivative. So a equals to the derivative. So 2e to the power of t, that is still 2e to the power of t, plus 8e to the power of negative t. So the derivative of e to the power of negative t, so the derivative of negative t is -1, so that becomes -8 to the negative t. And that's our acceleration. Find the time when the acceleration of the object is 0. Okay, so 0 equals to 2e to the power of t minus 8e to the power of negative t. So we can actually, what can we do here? Okay, so we can say that 8e to the power of negative t equals to 2e to the power of t. Okay, so we can rewrite this as this equals to 2e to the power of t. So therefore 8 equals to 2e to the power of 2t, because when you e to the power of t times e to the power of t, that equals to e to the power of t plus t, which is equal to e to the power of 2t. So 4 equals to e to the power of 2t, and therefore if we take the natural log of both sides, so natural log 4 equals to 2t, so therefore t equals to ln of 4 over 2. What is this? Equal to ln of 4 over 2. That should give us a time of 0.693 seconds. 693. And that is a merit level question. To get an achieved, all you need is a correct derivative. So to correct derivative, that's just the first step here, will get you an achieved. Alright, so on the last question now. The graph below shows the function y equals to 2 root 36 minus x squared, and the tangent to that function at point P. The tangent intersects the x-axis at point 80. Find the x-coordinate of point P. Alright, so first things first, if you want to find a tangent, you're going to need to find the derivative. So y, not red pen again. Okay, so y equals to 2 root 36 minus x squared, if I'm correct. Yeah. So if we rearrange the square root to the power of 1/2 instead, we can differentiate. So we're going to use our chain rule again. So dy over dx equals to 1/2 times of 2 is just 1, so we don't need to write anything in front of it. To the power of negative 1/2 times by the derivative of the inner function, which is negative 2x. So negative 2x over square root of 36 minus x squared, that's our dy over dx. Alright, so our dy, that's our gradient. So right now we need to find another equation for our gradient. So that's our gradient function, but we need to find another we need to find another equation for our gradient and make them equal to each other to find it. So for P, we know it passes through 8, 0, and we'll call this point x, y. So we know that our gradient is equal to our rise over run. So as you can see, our rise in this case is actually negative y. So because it's a negative gradient, so our gradient is actually negative y over x. 8 minus x. I believe that is correct. So negative y over 8 minus x. Yes, okay, I believe that's correct. So our y in this case is y equals to 2 root 36 minus x squared. So we'll have negative 2 square root of 36 minus x squared over, we had 8 minus x, that's our run. And that's also equal to our gradient, because of rise over run, okay? So now we can make them equal to each other actually. So we can say negative 2 root 36 minus x squared over 8 minus x, that's equal to negative 2x over square root of 36 minus x squared. Alright, so a little bit of rearranging we need to do here. So we can cross multiply, so negative 2 times of 36 minus x squared is equal to, what am I doing? Oh, it's equal to 8 minus x times of negative 2x. I believe that's correct. Cross multiply. Yeah, that is correct. So we'll have negative 72 plus 2x squared is equal to negative 16x plus 2x squared. So good thing is that 2x squared cancel out. So you'll have here, so I will move over here. So we'll have that negative 16x equals to negative 72. And therefore 72 over 16 should give us an answer of x equals to 4.5. Or if you like fractions, then you should get 9 over 2. And that is your final answer for this question. So this question was actually challenging in the term that you had to find another equation for the gradient, but that is just the rise and run. So for this point P, you can just let it be x, and this point is x, y. From point P, changing like this rise over run is here. So this change of y is negative y, and the change of x would just be this x point, and this 8 here, so 8 minus x will be the change in x. So this is change in x, which is equal to 8 minus x. I hope you can see that there. So 8 minus x is the change in x, and because it goes from point P, so that's xy to 0, the change is negative y. So I hope you understand that, and that is an excellent level question with a merit grade being awarded with... Oh, it's a long one. Correct dx. Correct dy over dx of the curve. So dy over dx, that's one part, and you also need to correct the gradient of the tangent. So I'm assuming that you also need this, like both of them, to get a merit grade. For an achieved grade, just to correct dy over dx, it will get you an achieved. Alright, that's it for this paper. I hope you guys enjoyed the video, and I hope to see you all